Good afternoon, everybody. Welcome to Chem 170 with your host, me, Dr. White. As you can see, my air conditioner is doing real well. It's actually cold in my office, so I put this on, even though it's warm outside. All right, tonight or this afternoon, I will be going through a review for test number 1. And let's go to Blackboard, the wrong school, D2L. And on Wednesday, because I forgot when I did the syllabus that June 19th is the federal holiday, Juneteenth. It's new and I forgot. And luckily I remembered, so I can't give a test on that Thursday. So I moved it to Wednesday. All right. Now, test number 1 will cover alkanes, which I'll do this afternoon, cycloalkanes, alkenes, alkynes, and aromatic compounds. Excuse me. And the point breakdown for the type of questions, 13 are general knowledge, 45 are nomenclature, and 47 are reactions. Nomenclature, if you've been doing the problem sets, and I hope you have, are 2 types. One is, here's the structure, give the IUPAC name. The other is, here's its name, draw the structure. And when I say draw the structure, I don't want you to put the empirical formula, 5 carbons, 8 hydrogen. Actually, like I've done in the videos, draw the structures. And you will have until Friday, 8 p.m. to upload your answers for test number 1 as a single PDF file. Now, some of you have already done for the lab. If you don't have a printer, just write out the answers for each of the questions on test number 1. Put them in order, 1 through whatever. Don't hide them all everywhere. I had one student do that last semester. Have to train that person. Now you go 1, 2, 3, 4, like that. And you can write them down. You don't have to write out the questions. This is your answers. Then when you upload it as a single PDF file to D2L, you can either use your scanner, like I have my printer scanner there, or if you don't have one, use your cell phone and use Cam Scammer, which some of you have already been using for the labs. Remember, when you use Cam Scammer, don't buy the one with the bells and whistles. Just use the free version. It works well. Now, when you are going to take test number 1, you'll see it in the assignment area of D2L. I don't have it there yet. I'll probably put it in there tomorrow. And then on Wednesday morning, 8 a.m. or maybe even earlier, I will send out an email that has the password that opens the password protected PDF file for test number 1. And like I said, you don't have to print it out. You can just write the answers and look on your screen, whatever it is, tablet, computer screen, cell phone even, and you can get the questions. Now, please do not cheat. And that means you should not talk to other people. You should not go to your notes, and you should not go to the internet, especially using an AI. I have put things in the test that will let me know if students are doing that, and I will do that. What's in my syllabus if I catch someone cheating, so please don't. If you've done the practice problems, hint, you'll do well. All right, now one other thing I want to show you in D2L If we go to content, then click on lectures. And this is because D2L is very old software. We scroll all the way at the bottom. See where it says load more? You're going to have to click on that, which I'm going to do now, left mouse click. And now you can scroll down and you'll be able to download test number one review. I have it both as a Word document, which I'll be using tonight, and as a PDF file. So if you don't have MS Word, you can still open it up with the PDF document, which will open up on any platform, including, I believe, your cell phone, even though I've never opened up a PDF file on my cell phone. And please upload your test on time by the deadline. I will be checking my email Wednesday and Thursday, even though it's a holiday. Don't tell anybody. And also Friday until 8 p.m. and actually later. So if you have any questions during the test, email me. Remember, I've said it many times in my video. There's no such thing as a dumb question in my class or my universe. And so if you have a question on the test, ask. I'll try and answer it. I won't give you the answer to the problem, but I will help you if you need clarification or if you're a little confused. All right, let's get going. I should mention I'll be posting this in my YouTube channel later tonight or early tomorrow morning. All right, let's start out. Hint, you should know what is a hydrocarbon or hydrocarbons. Those are molecules with only carbon and hydrogen atoms. Now, there are two types of hydrocarbons you should know. One is a saturated hydrocarbon, and that's a molecule, since the hydrocarbon with only carbon hydrogen atoms, in which all the carbon-carbon bonds are single bonds. The other type is unsaturated hydrocarbon. And again, being a hydrocarbon, it's a molecule with only carbon hydrogen atoms and contains one or more carbon-carbon multiple bonds, meaning a double or triple bond. So saturated hydrocarbon, molecule with only carbon hydrogen atoms, and all carbon-carbon bonds are single bonds. That's saturated hydrocarbon. Unsaturated, excuse me again, are molecules with only carbon hydrogen atoms and contain one or more carbon-carbon multiple bonds, such as a double and triple bond. Now, I won't ask a definition of alkanes or cycloalkanes, but an alkane is a cyclic saturated hydrocarbon, and a cycloalkane is, and that should be, a mistake. Don't look, don't look. A cyclic saturated hydrocarbon. Now, you should know how to draw alkanes and cycloalkanes. And the first thing I have to remind you is on test one, and all my tests, remember there are 4 bonds to carbon. 4. Well, I got to get that finger fixed someday. 4 bonds to carbon. 4. I don't have it on, but a number of years ago, a couple of students of mine at the end of the semester gave me a T-shirt they had made up 4 bonds to carbon, and on the back was methane structure. It was cute. I wear it once in a while. But remember, 4 bonds to carbon is your friend. So if I were to ask you to draw the structure of propane, you've learned the alkane names 1 through 10. Propane has 3 carbons, and I know each carbon should have 4 bonds, and this one has 1 bond. 4 minus 1 equals 3. So I know there are 3 hydrogens there. This has 2 bonds. 4 minus 2, why 4? Because there's always 4 bonds to carbon. So that'd be 2. So there are 2 hydrogens. And finally, the last one, same thing, 1 bond. 4 minus 1 is 3. And that's what I mean by drawing the structure. And you should know how to do that. Now, for a ring, and I'll go through nomenclature in a second. This is a 6-membered ring. And we don't show hydrogens on a ring. And if we look at this carbon here, it has 2 bonds to it. So what you don't see are the 2 hydrogens, which would be on every carbon of that ring. So you should know how to draw alkanes and cycloalkanes. All right, now, I taught you that IUPAC, which I like to say because I think it's cute, really cool, International Union Pure Applied Chemistry, which I'll never ask you on a test, is the official organization that is existing to mainly come up and keep current ways to name molecules, all chemical, but the bulk of their work is for organic because that's the best. And you should know that. You should know how to be able to identify the longest chain, which I went through in the video. And based on that, what's the root name, the alkanes 1 through 10? It goes much higher, up to 1,000. But for everything we use in our daily life, 1 to 10, you can get by, and that's what I teach. And there's a file, the IUPAC names of the alkanes, that is in the lecture section, and you should know those 10. Now, alkyl groups, which when we get into nomenclature, are what's left over after you name the main chain. And CH3 bonded to something, that's what this line means, is a methyl group. 2 carbons is ethyl. Now, when you have 3 carbons, there's 2 possibilities. When the N carbon of the 3 carbon is bonded to the chain or the ring, that's N-propyl. When the center carbon of the alkyl group of 3 carbons is bonded to a ring or a long chain, that's called isopropyl. And then 4, there are 3 of them, but 1 I've never used, so I don't teach it. So if I haven't used it in all the years I've done organic, you won't either. So that's why 4 carbons, the N carbon is the N-butyl group, and 4 carbons with a carbon with 3 methyls on it, and that center carbon is bonded to a ring or the chain. That's called a tert-butyl, and you know organic chemists are lazy, and we just call it a T-butyl group. Dr. White loves T-butyl groups, and isopropyl and methyl are cool too, the others too. Now, when I'm talking about general knowledge, and I think I spelled Vaseline wrong. There, it's better. But anyways, you should know, example, where would you find alkanes in your daily life? Well, natural gas that you cook with, like I have in my house, is methane, an alkane. Propane for your barbecue, it's in the white canister unless it's got propane. Gasoline contains about half alkanes. Vaseline, also known as the common name petroleum jelly, is longer chain alkanes. So is baby oil, and very long alkanes, half the weight of candles, are alkanes. Now, I only asked you to learn one general reaction. Remember, the general reactions are like your roadmap. They tell you what products you should be getting in a reaction. Now, here I have alkane, and it could also be cycloalkane, plus oxygen gives you carbon dioxide, water, and heat. Now, heat is not considered a chemical. So on the question, if I asked you what would be the products if we were to take propane, if I were asked give all the product or products for the following, well, this is an alkane, oxygen, and my general reaction tells me I get carbon dioxide and water. So the answer here would be CO2 plus water, H2O. Now, in this class, you never, ever, ever have to balance an equation. You don't. All I'm interested in, that's mainly in organic, it's that way, are the products, what you make. Sometimes I'll ask you at the base of the arrow, what would be the starting materials or reactants? All right. Now, next chapter or area, we talked about the alkenes, which are carbon-carbon double bonds shown by two lines, and the alkynes, a triple bond shown by three lines between two carbons. Now, you should, excuse me, you should know an alkene consists of one pi bond and one sigma or single bond. An alkyne consists of two pi bonds and one sigma bond. Double bond, one pi, one sigma. Triple bond, two pi, one sigma. Now, how do you name these? By the IUPAC or official name. For a double bond, find the longest chain that has both carbons of the double bond, or it could be also a ring, and drop the A on the ending like butane and put in butene. Now you need a number, and I'll show you in a second, for acyclic. Plus, if needed, is it cis or trans? And no number or cis or trans for cycloalkenes, because the cycloalkenes we have in our class, and I've only seen, except for one many, many, many years ago in an obscure paper, are always cis. Now, for a triple bond, find the longest chain that has both carbons of the triple bond, name it as an alkane, drop the A on the ending, and two mistakes. I'm sorry, I'll have to try and put in YNE and a number. And the number is the carbon closest to the end of the chain that has the one of the carbons of the triple bond. And if I were to ask you, give the IUPAC name for the following, and one of the things you should be doing, and you hear me mention it many times in the video, hopefully you've been watching the videos, and that is look for what's different when you look at a molecule, organic molecule. What's not carbon, what's not hydrogen, should get your attention like that. And what's not a carbon-carbon single bond. And here we have a double bond. So how do we name this? Find the longest chain with both carbons of the double bond, these. And that would be this. I could have used the other methyl group too. And how many carbons are there? Well, let's count. 1, 2, 3, 4, 5. That would be pentane if it were an alkane, but you drop the ane and put in ene, pentene. Now, what carbon double bond is closest to the end of the chain gets the lowest number, which is this carbon. So that means I'm going to start numbering 1, 2, 3, 4, 5. And the lead carbon of the double bond is carbon 2. So it's 2-pentene. Now, if you notice on each carbon of the double bond, we have a hydrogen. So we can have cis-trans isomerism. And if I had a plane going here, these hydrogens are on opposite side. If they had been on the same side of that plane, then that would be cis, but they're opposite. So this is trans. Are we done yet? No, because we have our whole friend, the methyl group, and therefore in front here, we have methyl. And what carbon is it on? 4. So this is 4-methyl trans 2-pentene. Say that 5 times quickly. That's a mouthful. And that's how you do double bonds. If it's in a ring, one of the carbons will always be carbon 1 and the other 2. And you do it in such a way to give the lowest numbers to also the alkyl groups. So in this one, this is 1, this is 2, this is 3. If I went the other way, this would be 1, 2, 3, 4, 5. So which is lower number, 3 or 5? The answer is 3. So first of all, how do we name this? It's a ring, 5 carbons. Rings are cyclo. Don't forget to put the cyclo when you have a ring. Pentane. It's a double bond, pentene. And one of the carbons is going to be number 1. So I don't have to put that. And cis, I don't have to put that. And then this would be 3-methyl cyclopentene. Now, triple bonds, many, many, many years ago, same obscure paper, I think, I saw a ring with a triple bond. In my experience, I've never come across one other than that one time. So for everything you're going to do, you're not going to see a triple bond in a ring. And here, look for what's different. Triple bond. And how many carbons in the longest chain? 1, 2, 3, 4, 5, 6. That'd be hexane. But drop the ane ending. And it's a triple bond, put yne, hexine. And then you have to say, in this case, which carbon is closest to the end of the chain. And if I started numbering the other way, you have two choices, 2 or 4, which is a smaller number, and hopefully I'll pick 2. So this would be 2-hexyne. And that's how you do the nomenclature. Now, if you notice, that's a bad habit of mine, I usually will draw a structure, but you should on a test, if I were to ask draw the structure of 3-methylcyclopentene, you should be able to draw a structure like this, or most of you would probably draw it this way, which would be totally correct. Double bond, 1, 2, 3 methyl group. Those are the two types of nomenclature question. Now, let's talk about the reactions. The first one is if you have a double bond and react with hydrogen and a catalyst, and the catalyst can be nickel, platinum, or palladium, you break the pi bond, and each carbon of the double bond gets a hydrogen. And same thing if you have a double bond reacted with halogen gas, HX, I'm getting ahead of myself, X2, and X can be fluorine, chlorine, bromine, or iodine. You break the pi bond, and each carbon of the double bond gets a halogen. Now, you're going to have two friends you should use on test number 1 and 2 and 3 and 4 and the final. The first one is how many bonds to carbon? 4. 4. Oh, gotta get that finger fixed. 4 bonds to carbon. And remember, when you're drawing something, check. If you see a carbon with only 3 bonds, it's going to be wrong. If it's got 5 bonds, guess what? It's going to be wrong. I'll bet on it. And I don't know if you've heard in the video, but I'll tell you now, I only bet when I know I'm going to win. So when I say I'll bet on it, I already know I won. So never bet with me. But anyways, remember, your two friends are 1. There's 4 bonds to carbon. 2, do you break carbon-carbon single bonds? No. What does that mean? And if I were to ask on a test, 3 points, give the product or products for the following. When I say give, and I think on this test, I finally changed it, draw, you should draw the structures. So you look for what's different. Ooh, a double bond. And I'm reacting with bromine gas, Br2, like this, where X can be fluorine, chlorine, in our case, bromine, or iodine. And you break the pi bond, and each carbon gets a halogen. Now, do you break carbon-carbon single bonds? No. So if I have 1, 2, 3 carbons, I better end up with 3 carbons like that. And which are my 2 carbons of the double bond? These. Which are these? And those 2 carbons, you break the pi bond between it, which I did right here. And each one of these carbon gets a halogen. What's the halogen? Bromine. And then you know there are 4 bonds to carbon, so you can put in the hydrogens. This bromine to carbon counts as a bond. So the center carbon has 3 bonds. 4 minus 3 is 1 hydrogen. and the N carbon has two bonds to it. 4 minus 2 is 2. And that's how you do it. And you saw I don't break the single bond, but pi bonds, oh, I can have a lot of fun breaking it, and I have. Now, both of these are symmetrical addition. You're adding the same thing to each carbon of the double bond. What happens when you have unsymmetrical? And the example, if you have a double bond, you add HX, and X, excuse me, getting all choked up over this exciting stuff. Oh, that was bad. I'm sorry. Bad joke night. But anyways, you have chlorine, bromine, or iodine could be X. You break the pi bond. One carbon gets H, the other gets X, and it follows Markovnikov's rule. I abbreviate M because I always spelled his name wrong and have to look it up. And that wasted a lot of class time. So I just put down M's rule, but I do honor his great work, which it is, by saying his name. So how does this work? And if I were to ask you, draw the reaction product or products, organic reaction product or products for the following, what do? We look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, oh, a double bond. And we're reacting it with HI. Iodine is the halogen. We abbreviate by X. Remember, X can be chlorine, bromine, or in our case, it's iodine. And you break the pi bond, one carbon gets H, the other gets X, and it follows Markovnikov's rule. And what is that? The carbon with the most hydrogens of the double bond gets the hydrogen, and the other carbon gets the halogen. So now you have to use your high-level math skills. Remember, you can't use a calculator during my test. And we see this carbon of the double bond has two hydrogens. This has one. Now, do you break carbon-carbon single bonds? No. So I start with 3. I better end up with 3. The N carbon has two hydrogens, which Markovnikov's rule says that will get the hydrogen from HX or HI. The other carbon of the double bond will get the iodine. And I know there are 4 bonds to carbon, so I can put in my hydrogen. The halogen counts as a bond too. And that's what you're doing. Now, if you want to, and you don't have to, you can take this hydrogen, move it up, and another way of writing this, which would be also correct, and let's call this A and B. Either one would be correct on a test, but I'd recommend you do A. Why? Well, it's one less thing you have to do in your head during a test that you could mess up. So do the easier way. I know some faculty organic, oh, you have to do it like B. Nah, do it the easier way. If you can write A, you've shown me you know this reaction. And that's Markovnikov's rule. The hydrogen goes to the carbon with the most hydrogens in double bond, in this case, the N1, and the halogen goes to the other carbon in double bond. This one. And that's how you do Markovnikov's rule. Now, another example of unsymmetrical addition is the addition of water to a double bond called hydration of a double bond. I will never ask you what are the names of a reaction on a test or at a final, but I do use them in class. Now, H plus is an acid catalyst. It could be sulfuric acid or other acids that I never talk about really in this class, like methane sulfonic acid or toluene sulfonic acid is another one, PTSA is called. But anyways, we abbreviate an acid catalyst by H plus, and water is H2O. Now think of water as HOH. You break the pi bond, and one carbon gets the H, and the other gets the OH. And it follows Markovnikov's rule. The carbon with the hydrogen, most hydrogens in a double bond, gets the hydrogen H from water. The other carbon double bond gets the hydroxyl group OH. And we'll learn later on the semester, this is a nice way to make alcohols. And I'll teach you what alcohols are later. We get into a lot of great stuff this semester. All right, now let's look at triple bonds. Triple bond has 2 pi bonds and 1 sigma. The sigma you don't break, the pi bonds you can break like that. And I have. And here, when you add hydrogen, since organic chemists are lazy, and we are, and we don't want to balance the equation, you need more than 1 molecule or mole of hydrogen for this reaction. We use bracket, the letter X, the letter S, close bracket, and that means excess. And what it really means is you've got all the hydrogen in the world, that anything that can react with hydrogen will be able to react with hydrogen. So you don't have to balance the equation. Yay. Catalyst is still nickel, platinum, and palladium. Since there are 2 pi bonds, each pi bond, each carbon of the triple bond gets a hydrogen. Since there are 2, each carbon gets 2 hydrogens. Now the same thing happens with halogenation. 2 pi bonds. Again, I don't want to have to balance it, so I'll use bracket, X, S, close bracket, meaning excess. I have all the halogen gas I need to react with the triple bond. And you break the 2 pi bonds, and each pi bond, each carbon of the triple bond gets a halogen. 2 pi bonds, each one gets 2 halogens. Now, one thing I want to mention, oops, wrong place. Let's go here. If you have more than 1 double bond in a molecule like this one, and if it's separated by 1 or more carbons, like this one is, then each double bond reacts like it's alone. Again, when you have more than 1 double bond, and each double bond is separated by 1 or more carbons, they act like it's alone. So if I were to take this molecule and react it with excess chlorine, why excess chlorine? Because you have 2 double bonds. Well, chlorine will react with a double bond like this. And remember, X can be, in this case, fluorine, chlorine, bromine, or iodine, the halogens. Well, I have excess here because I have two double bonds. Now, do you break carbon-carbon single bonds? No. So I have 5 carbons across. I break both pi bonds, one for each double bond, and my general reaction says each carbon of a double bond gets a halogen, in this case chlorine. And the other double bond, same thing happens. And now I know there are 4 bonds to carbon. And I can put in my hydrogens. The chlorine counts as 1 bond. So whenever you have double bonds, more than one, like 2 in a molecule, and they're separated by 1 or more carbons, each one reacts like if it was alone. Now, one other thing I had mentioned in the video, and I'll mention now. I've been teaching Chem 170 at ECC since at least, I think it was 2003 or 4 I started. Wow, that's a while ago. Anyways, some of my best students in 170 always on their tests wrote the general reaction down underneath the specific reaction like I do. Some of my best students in 170 never wrote the general reaction down, but they had it up here. They memorized it. So you can do either way. I don't care. Whatever works for you. Next, let's talk about aromatic compounds. Now, the first one is benzene. And benzene is a 6-membered ring that can be written with 3 double bonds this way, or a circle. I like the first 2 because I just think it looks cooler. But anyway, and here, you can write toluene, that's a methyl group on a benzene ring. So used to not doing this, or you could do it that way. Now, on a test, if I ask draw the structure of benzene, this is very important, and you do that, I'm going to mark it wrong because this is cyclohexane. If I ask draw the structure of benzene, you need to put the double bonds in there of the circle. Now, this is correct because that is benzene. Now, at this point, I taught you some new substituents besides the alkyl groups, and Cl is called a chloro group, F is fluoro, Br is bromo, iodine is iodo, and NO2 attached something is the nitro group. Next, I taught you the classic old numbering system for disubstituted benzene ring. If it's 1,2 disubstituted, it's called ortho. If it's 1,3 disubstituted, it's meta. And if it's 1,4, it's para. Now, in toluene, the methyl group counts as a substituent, even though it's in the name. So if I were to have something like this, what would be the IUPAC name? Well, you look for what's different. Ooh, a ring with 3 double bonds that are alternating single, double, single, double. That's a benzene ring, but there's a methyl group, so that's toluene. And as soon as I say toluene, that's spoken for. And here we have chlorine, so that's a chloro group. And if we look at this, on this ring, this is 1, 2, 3, 4. So it's 1,4 disubstituted. 1,4 is para. And that would be parachlorotoluene. Now, if you have more than 2 groups, use the regular numbering. And I showed you in the video, like 2,4,6 trinitrotoluene, which is also known as TNT, an explosive. Now, one of the problems with a benzene ring is the double bonds make it very stable. And that's called the aromaticity of the benzene ring, or an aromatic compound. And some of our spices are very stable because they have aromatic rings in them. One in particular, I'm just off the top of my head, cinnamon. Dr. White loves cinnamon, but even more, vanilla. And I'll teach you more later in the semester about those. And because of that, you don't break those double bonds. What you do is called a substitution reaction. One of the hydrogens on the benzene ring is substituted. And here, if we take halogen gas, or halogen X2, but for the aromatic rings, unlike a lone double bond, you need a catalyst, ferric trihalide. And in real life, you only use chlorine or bromine. You replace one of the hydrogens with a halogen. Now, I mentioned, what if there was something already on the ring? Well, that opens up a whole area called substituents and directors on a ring. We'll do a lab with that, but I won't put it on the test because I'd rather spend more time you learning about things that are important to you, like carbohydrates, proteins, and fats and oils later in the semester, than wasting time on something you'll never do the rest of your life, but still you should know about. So therefore, this is the only reaction where either X is chlorine or bromine on test 1. Now, if you have a benzene ring and react it with nitric acid, HNO3, and sulfuric acid, H2SO4, you put a nitro group on it. And again, this is the only reaction, because I'm not going to have a substituent on a ring to start with, that I can ask you. Remember, it's NO2, not NO3. Nitro group is NO2. Now, if you take a benzene ring and react it with sulfur trioxide and sulfuric acid, you put on what's called, and I didn't ask you to learn this name, but it's called a sulfonic acid group. And a sulfonic acid group on a benzene, which I'll show you way later in the semester, is the basis for all our detergents. If you use Sheer, All, or whatever to clean your clothes, you're using something that originally had a benzene ring sulfonated, then made into something else. Again, this is the only reaction I can ask you on test 1. But the final one is Friedel-Crafts alkylation. And we honor the 2 great organic chemists, Friedel and Crafts, who discovered or created this, invented this. If you start with a benzene ring and react it with an alkyl halide, RX, and remember, R is anything just with carbon and hydrogens. And one of the carbons says a halogen, and you need aluminum trihalide, where X is chlorine or bromine, you make that very special, very rare thing, a carbon-carbon single bond. And the bond from the ring, benzene ring, goes to the carbon in the R group that had the halogen on it. That's important. If you put it on a different one, I'll mark it wrong. And let's take a look at what I mean by that. If I were to ask you, give the organic product or products for the following, what do? Well, you look for what's different. Ooh, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. And we have a benzene ring that got my attention. Then here we have carbon, ooh, carbon with a chlorine, halogen, and a carbon. So this would be our X. And this is my R group. And then I also have this catalyst, aluminum trihalide, where X can be chlorine or bromine. In our case, it's chlorine. And you form that very special thing, a carbon-carbon single bond to the R group, to the carbon that has the halogen. That's this carbon. So our general reaction tells us we get a benzene ring. Don't forget to put the bonds in there. And then do you break carbon-carbon single bonds? No. So I have 3 carbons in my R group. The center carbon has the halogen, and that's the one that you form this carbon-carbon bond. And there are 4 bonds to carbon, so I put the hydrogens and the carbons that are not in a ring. Now watch closely. Mistakes sometimes students will do for this problem is this. And that's wrong. Why? Because that's the cyclohexane ring. Don't forget to put the bonds in to make it a benzene ring. Because if you didn't put those red double bonds in there, that's cyclohexane, and I give you 0 points. Don't come asking, can I get partial credit? No, it has to be a benzene ring. So that's important. With that, I'm done. I'll stick around if anybody has any questions. Remember, do the practice problems. After test 1, you'll know why I'm calling them practice problems. Hint, big hint. And one last thing, I'd like to thank all of you. You've all been handing in your labs. I've been grading them. I'm a little behind. I'll try and catch up tomorrow. If you don't get 11 points, which is meaning the maximum amount, 11, which means your lab is perfect, I will send out an email to show you what you did wrong, what questions you got wrong. I'm just a little behind in that. Sorry about that. And don't forget, Wednesday night at my normal time, and also tonight at 6:30, I'll have my office hours. If you have questions, come on by. And with that, I'm done. And you know what I'm going to say yes next, and that is Gehen gesund, which is Yiddish for going hell. And I'll say, I'll stick around, but I'll still do my normal ending. Bye now. Bye. I stole that from Granny and the Beverly Hillbillies. Bye.